Hey everybody, here is our next set of notes. We're going to cover reciprocal and quotient identities, which are written on the bottom of our half sheet as well. These are to help us prove why the trig ratios make sense, basically, why they're reciprocals of each other, and then how certain ones of them, tangent and cotangent specifically, how they come to be, because they're the division of two other ones. And then down here, we're going to prove why they're reciprocals. And over here, what we're going to do, this is my favorite part, I love this topic, is we're going to simplify expressions that we get down into just one trig ratio by using the identities to help us kind of switch stuff around. That's kind of very vague. It'll make sense later, I promise. Up at the top here of these notes, it says the last section of trigonometry that we're going to work with are called trig identities. The three types of identities are blank, blank, blank. There are three kinds of them. We're going to cover two of them today and then one of them next time. This first one is called reciprocal. And they are to prove why trig ratios are reciprocals, why you can just flip them over. The second type we have here as well are called quotient. And quotient identities explain why tangent and cotangent are the division of sines and cosines. And the last one are called Pythagorean. Pythagorean, as in the Pythagorean theorem, to prove how we use the Pythagorean theorem on the unit circle. Once we have an understanding of how to apply these identities, we're going to simplify and verify trig expressions and equations by using the identities. I've saved us a big space up here at the top to write the identities down. What we're going to do every time we're working with these is we're actually going to circle, write down the identity, and then highlight it within our scratch paper. It'll make sense once you see it a little bit more. This would be an easy way for me to see that you know what you're applying, basically. And here under the reciprocals, what I want you to do is just write down the normal trig ratios that we use in order. So normally we use sine, cosine, and tangent. And then the reciprocals of those three are cosecant, cotangent, or sorry, cosecant, secant, and cotangent in order. So cosecant, secant, and cotangent. I have them labeled here are 1, 2, 3, 4, 5, and 6. It makes it a lot easier to identify them based on that. It's also like that on the bottom of your half sheet, the one you'll be allowed to use on your final. Right here, it's labeled R1, 2, 3, 4, 5, 6. We also have Q1, Q2 for today. And then we're going to use P1, 2, and 3 next time. So let's fill in our Q1, 2. Q1 is saying that tangent is tangent because it is sine divided by cosine. And then Q2 says that cotangent, because it is the reciprocal of tangent, is just the flip over of that cosine over sine. Goody. Okay, let's give it a go. We'll do 1, 2, 3. You'll try 4, 5, 6. Number 1 says, if the secant of theta equals 3 over 2, use IDs to prove the cosine of theta. You should already know the answer to this. Secant and cosecant are reciprocal, so you just flip it over. So if secant is 3 over 2, cosine is 2 over 3. So we already know the answer. The answer is going to be 2/3. We want to prove why or how is the answer 2/3. That's the goal here. And we'll do that by looking at what is cosine. So cosine of theta equals, I'm going to look up here for a identity that starts with cosine equals. There is one here at R2, and cosine equals the reciprocal of secant, so 1 over secant. So on our question here, the cosine per R2 is 1 over secant. And I happen to have secant here. It is 3 over 2. This is really 1 over 3 over 2. And now I'm dividing by a fraction. Remember, the way you get rid of that, dividing by a fraction, is by multiplying by the reciprocal of the fraction. So we keep the top the same, we change to multiply, and then we do the reciprocal or flip over the bottom. So now I have 1 times 2/3. 1 times 2/3 is just 2/3, because 1 times anything is the other number. And this is what we thought it was going to be, remember? And that's how. I'm just going to highlight here this identity. That's what we're going to do every time. We're going to highlight it so you can see it a little bit better. Really, so I can see it better when I grade them. Let's be honest. Let's try another one. Number 2 says, if tan of theta equals square root of 3 over 4, use identities to prove the cotangent of theta. We already know the answer, right? We're just going to flip it over. So the cotangent is going to be 4 over square root of 3. But we want to prove how we got that. So I'm looking for anything talking about cotangent and tangent. So let's look up here. I have it twice. I have cotangent twice. This one's going to be about tangent because the cotangent is 1 over the tan. So let's look here for R6. It's a funky R, sorry. There we go. For R6, I'm just going to flip it over. So 1 over, kind of, 1 over the tangent is going to be 1 over, tangent is root 3 over 4. And to do that, remember I multiply by the reciprocal, so I keep the top, change to multiply, and I flip the bottom. Anything times 1 is the other number. And I just flipped it over. That's how I got here. Let's do it again. Number 3 starts with sine of 2/5. Use identities to prove the cosecant. Cosecant is going to be, flip it over, 5 over 2. We want to prove that. So I'm looking for anything that says cosecant. I'm going to look up here. Per R4, cosecant is 1 over sine. So I would have cosecant is 1 over sine. And that was R4. One over sine is 2/5. And I'm divided by a fraction, so I keep the top, change to multiply, flip the bottom. 1 times anything is itself. And we just flipped it over. Good. Before you do the bottoms, I do want to fill in the top just so you're not guessing. I'm sure you can follow the pattern, but just in case. Remember, it's going to be 1 over and then whatever the reciprocal is. Like that. And then a reminder, this is already written on your half sheet. It's typed in the box that says reciprocal identities or quotient identities. You can also get it off there. I am never going to ask you to memorize these. Good. So once you're ready, go ahead and try 3, 4, and 5, and then come back to check them when you're done. Here is the answers. Go ahead and check. For number 4, you should have gotten R5, and the answer was 2. For number 5, you should have gotten R3, and the answer was -1. And then for number 6, you should have gotten R1, and the answer was 1/2. Good. Let's look over here now. You'll notice there is an absence of numbers. There are no numbers on these kind of questions. All we're going to do is try to simplify as far as we can. And for these kind of questions, it will normally specify what you're going to simplify down to. I've already said up here at the top, use identities to simplify each expression down to a single trig function or a constant, which is just a number. The easiest way to do this is to convert everything over to sine or cosine first. There is a typo. There should be an E there. There we go. Okay, the reason we're going to convert to sine and cosine is so we only have 2 things to try to cross out as opposed to 6 different things. And it'll make more sense once you see it. So we're just going to jump on in. Number 7 says cotangent times sine. Or cotangent of theta times sine of theta. We already have sine, so we're good there. We want to convert everything to sine and cosine. Let's convert this one here. So I'm looking for an identity to invoke. That goes from cotangent to sine and cosine. I only have 2 that start with cotangent. This one isn't going to work because it goes to tangent, so it doesn't really help me. But this one does work. It goes to cosine over sine. So per Q2, cotangent is the same thing as cosine over sine. And then I was already multiplying by that sign. That sign didn't change because it was already a sign. And now I'm going to see if I can simplify just using normal math rules. I am multiplying, so if I were to do this, I'd multiply across top, multiply across the bottom, but I could simplify before I do that. I have a sign in the numerator and a sign in the denominator. Anything divided by itself is 1. So now I have left cosine times 1 in the numerator and just cosine on the bottom. No, just 1 on the bottom. Sorry, my brain was moving too fast. And cosine over 1 is just cosine. And that's the answer. Let's try another one. Number 8. See what we get. Number 8 says secant times sine. We already have a sine. We're going to keep sine the same. Secant we will transfer. So we want to look over here and find an identity that starts with secant that'll change us over into cosine or sine. And you can see that here on R5, secant is equal to 1 over cosine. So per R5, secant is 1 over cosine times sine. Now, there's nothing I can cross out here, so I am just going to simplify. Multiply across top, multiply across the bottom, just like a normal fraction. 1 times sine is sine. On the bottom, I got cosine. Now, this is not just one ratio. I could keep simplifying. I have sine over cosine, so what I'm going to do is look back over here and see if there's any way to simplify that down to just one ratio, because I know I'm supposed to be able to. And if I look, it's right here. This has sine over cosine, and that's the same thing as saying tangent per Q1. So Q1, and this is actually equal to tangent. And there we go. Okay. I want you to try number 8 before you, or sorry, number 9. Before you try number 9, just to let you know, this multiplies the same way that x would. So if you have like x times x, that would be x squared, or x squared divided by x would just be x because the one would cancel. Same thing for these. They're going to work exactly the same as a variable would. Okay. So go ahead and try number 9, and then come back when you're ready. Here is number 9. We used R4 to convert cosecant into 1 over sine. And then I was dividing by a fraction. So remember, I keep the top, change to multiply, and flip the bottom because I'm multiplying by the reciprocal. So I end up with sine times sine. And like I said, it works just like x. So sine times sine is just sine squared. Just make sure when you're drawing it that the sine is the part that's squared and not the theta. Okay, looking at the next one. Same exact process here. If you have it squared, it's just going to respond the same way as it would normally. You would just put the squared onto everything. So looking at here, I have a top of cosecant squared and the bottom is cotangent squared. So if I'm looking over here, I'm going to figure out how to convert these to sine and cosine. R4 will do the top, and then Q2 would do the bottom. So R4 and Q2. Per R4, cosecant squared is actually 1 over sine squared. And the bottom, per Q2, cotangent is actually cosine over sine. So if it's cotangent squared, we would just do cosine squared and sine squared. I am divided by a fraction, so I'll keep the top, change to multiply, and then flip the bottom. I'm just going to simplify where I can. I have a sine squared on top and a sine squared on the bottom. So I'd be able to cancel out both, right? Both sines on top and bottom, because I have 2 sines on top and 2 sines on the bottom. And then when I simplify from there, I get, so that's 1, there we go, 1 on top and cosine squared on the bottom. But I could still simplify this, so I'm going to look back over here, and I'm looking for 1 over cosine. You can see that right here, so that's actually the same thing as secant. So per R5, this would really be secant squared. It's squared because the cosine was squared. There we go. And that's how we did it. The next one, I promise, is a little bit easier. So pause and try number 11 and then come back when you're ready. Here is number 11. Like I said, this one's a little bit faster because you were able just to cancel. Like I said, this is just a little bit faster because you were able to cancel. So we have cosine times 1 over sine. That would give me across the top. Cosine times 1 would give me just cosine over sine. And then here, now I have cosine over sine divided by cosine over sine. You could multiply by the reciprocal and cancel everything out. Or you could see that we're dividing the same thing by itself. Anything divided by itself is 1. And that's how we got 1. Okay, good. So last one, try number 12. So pause, try number 12 and come back when you're ready. Here is number 12. You can see we had R5 on the top for the secant, and then Q1 on the bottom for the tan squared. And that gets me to here. And then I want to simplify the top before I try to divide or multiply by the reciprocal. These canceled out because I had a cosine on top and a cosine on the bottom. That just gets me 1 left on top. And now I'm still dividing by a fraction, so I'm going to keep it top, change and multiply with the bottom. 1 times anything is itself, so I'm just going to get cosine squared over sine squared. And then I could simplify this by doing Q2 to put me back into cotangent squared. And there we go. Good. The last thing I want to do, just where we have an open space here, I don't have one on here that specifies this, so I just want to talk about it. If you have a different number of them on the top and the bottom, let's say I had a cosine squared on top and a cosine on the bottom. If I were to cancel these, 1 would cancel off the bottom and 1 would cancel off the top to leave me with just a cosine on the top. Just to make sure. I know you probably understand that, but just in case, I've seen some people get stuck on the delta math, so. And there we go. Cool. Have a good day. Bye.